Now, we talk about the expression on the backboard, 4 plus 4 plus 4. Okay? What is another way that I can write that problem, not using addition, but using another mathematical operation? What is another way I can write 4 plus 4 plus 4, and where it gets the same answer, obviously? Brandon? 4 times 3. Okay? That's another way that we can write that expression. What's another way we could write it? Because of the commutative property of multiplication. Jesse? No. Not that. I understand what you're saying. You're just coming up with another expression. That's another way to write it. But what's another way I can use that information and write it? Levi? 3 times 4. Okay, 3 times 4 is the other way. We can write it as 3 times 4 or 4 times 3 because of the commutative property of multiplication. Remember, the commutative property of multiplication said I can take the two numbers and flip them when you're multiplying and you're going to get the same answer. Okay, so that is one way that we can rewrite 4 plus 4 plus 4, and it would be a way that we could simplify the expression. Now, let's look at the one that Trustin wrote on the sideboard, and he wrote x plus x plus x plus x plus 1 plus 1 plus 1. This is where people start getting confused. Okay? Now, can I simplify the 4 times 3 that I just said? What would be 4 times 3? 12. So I can simplify that to 12 and that to 12 and this to 12. I can simplify that. Okay? Now, I want to rewrite x plus x plus x plus x. How many x's do I have? 4. So that would be the same thing as 4 times x. Okay? How many 1's do I have? 3. So that would be the same thing as 3 times 1. Okay? Can I simplify 3 times 1? What is 3 times 1? 3. So yes, I can simplify 3 times 1. That is 3. Can I simplify 4 times x? Do I know what x is? No. Okay, I cannot simplify 4 times x. So that is the expression in simplest terms. That is where people go, well, it's 7x. No, we don't have 7 x's on the board over there. We have 4 x's. We don't know what x is, so we can't take it any further but say 4 times x. Okay, you can't take it and say that I'm going to multiply 7 times x. Just like if I gave you this problem. If I gave you this problem right here, 4 times 2 plus 3. Jesse, what would you do first in 4 times 2 plus 3? Multiply 4 and 2. Okay, so if you can't multiply 4 times 2, then you can't go any further than that. That's as far as you can go. Nobody in here would say, oh, that's 7 times 2. But yet, I'll put an x with it, and you'll go, that's 7x. No, it's not 7x. It's 4 times x. I don't know what x is. And order of operation says you have to do what? Multiplication or addition? Multiplication. So I can't do anything else. I'm done. I'm done with the problem. That's as simple as it will go, is the 4x plus 3. Now, the 4 times 2 plus 3, yeah, I can simplify that. That goes to 8. Then I have 8 plus 3, which is 11. Those simplify. Okay? So, that's what we're going to discuss today. We're going to talk about simplifying expressions. Okay, just like when we had the 4 people with red shirts stand up, they stood up, we had 4 red shirts. Then we had Jacob stand up who has a white shirt, and we said, do we have 5 red shirts? No. We have 4 red ones, and we have 1 white one. Okay, Brandon.
Why can't it be 7x?
Why can't it be 7x? Why can't it be 7x? Is there 7x's on that board over there? It can't be 7x. Because the problem 4 times x is x plus x plus x plus x. The reason 4 times x is x plus x plus x plus x is because the addition and multiplication are related to each other. They undo each other. In other words, 4 times 2 is 8. Okay? Well, 4 times 2 is 8 is the same thing as either 4 plus 4, 2 times, or 2 plus 2 plus 2 plus 2, 4 times. Okay? That's how they're interrelated to each other. That's all multiplication is. Instead of us going 10 plus 10 plus 10 plus 10 plus 10, we say 5 times 10. Okay? Instead of taking 8 times 7 and going 7 plus 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 7, we just say 7 times 8. But what do a lot of you do when you get to those areas where you have struggles? You go 7, 14, 21, 28, 35, 42, 49, 56. Oh, it's 56. Okay? And that's how they teach you when you start out. That's how they teach you to multiply. 3 times 7. What is 3 times 7? It's 7 plus 7 plus 7. Okay? So addition and multiplication are interrelated. So when we have 4x, that's all we can do. What if we had this? What if we had x plus y plus y plus y? How many x's do I have? 2. So that would be 2x. How many y's do I have? 3. So that would be 3y. So can I say that I have 5 x's? Is there 5 x's in that original problem? No. Can I say I have 5 y's? No. All I can say is I have 2 x's plus 3 y's. And that's your answer. That is simplified in lowest terms. Can't go any lower. Now, if we happen to know the value of x or the value of y, then yes, we could go further. But we don't. That's all we know. Okay, now, I want you to look at, let me get the page, get on that first page of 7.2. What page is that, Tristan? 3 what? 322. All right, there's some definitions that we need to go over, okay? And I'm going to, let's see here, real quickly, go here, day 2, day 3, okay. I'm seeing if I typed them out. I didn't, okay. All right. Let's look at the very first one. Very first definition that I want to look at is terms. Okay? Terms, when we're talking about mathematics, terms are the parts of the expression that are being added together. Okay, now, we have said in Chapter 6 that you can change subtraction to what? Addition. Okay, so realistically, anything that I add or subtract together is a term. Okay, so let's look at this problem here. 7c plus 9 minus 3c. In this problem, Jacob, How many terms do I have? Just take a guess. 2? No. Jesse? 3? Why? Okay. There are 3 terms. 1, 2, 3. All those numbers, or the number and letter in 7C, is 1 term. The 9 is 1 term. The 3C is 1 term. Okay? So there are 3 terms in this problem. Eventually, we will simplify it down to 2 terms. But right now, there's 3 terms. Okay? So terms are the parts that you're adding together. A term can look like this. How many terms are in that problem? 2. Okay? Even though 3A, B, C, D, that's multiplying A times B times C times D, that's 1 term. Even though it has multiple numbers and letters, it's still only 1 term. 4 is 1 term. Okay? We call 4 a constant. What does the word constant mean? Tayshawn? Ongoing. Good definition. What else can constant mean? If I go at a constant speed on my trip, what does that mean, Quade?
Consistent.
Consistent. That's another word. Kennedy?
Reoccurring.
What? Reoccurring, that's another word. I'm looking for one that's simpler, though. If I'm going the same, oops, my bad. Constant means the same. If I'm going constant speed on my trip, I'm going the same speed. Reoccurring, same thing. Okay? All the ones y'all were naming were another way to say the word same. Okay? Does the value of 4 ever change? 4 is always 4. If I say 4 plus 2, that's always going to be 6. Because 4 is always equal to 4, and 2 is always equal to 2. They're constants. Okay? So a constant is a number term by itself. Now, that number term could be 1. That number term could be 1,256,000. Okay? Doesn't matter. It is a number that is by itself. Okay? A while ago when we said 3x, 3 is not a constant. Why? Why would 3x not be a constant? Because it has the x, but how is the x going to change 3? Right, we're going to have to multiply x, and we don't know what x is. So is 3 going to be equal to 3 and 3x? No. Well, it could be, because x could be equal to 1. But does it have to be? No. If I just have plus 3, does 3 equal 3? Yes, it does. If I just have a 3, it's got to equal 3. Okay? So 3, any number by itself, is a constant. Let's look at the next word. The next word starts with a C as well, but it's called coefficient. Okay? Coefficient is the number, also called the constant, in front or multiplied by a variable. So a coefficient, and they're more commonly, some people call them numerical coefficient, okay, because there's different types of coefficient. But for our purposes, we're going to call it a coefficient. The coefficient is the constant or the number that is in front or multiplied by the variable. So, for example, 3x. Okay, 3 would be the would be the coefficient. 22y. 22 is the coefficient. Okay, 48ab. 48 is the coefficient. Okay, so those are all coefficients. So, we got a question for you. I'm going to give this one to Jess because Jess is on a roll today. Jessie, what is the coefficient of x? Huh? Yeah, that's a good guess, but no, that's not it. No. Let me ask you this. How many x's do I have? Then that is your coefficient. 1 is the coefficient of x, or any variable that doesn't have a number in front of it. Okay? So 1x. Okay, so if I have just a y up there, the coefficient would be 1. You don't have to put the 1, because here's why. When we went over here and we said x plus x plus x plus x, how many x's do we have? 4 x's. Because there's 1x plus 1x plus 1x. Okay, that's why we have 4 x's. All right? Now, here's one that is a little bit sneaky. 1 minus 3x. 1 minus 3x. What is the coefficient of 1 minus 3x? Isaiah, what is the coefficient? No, you're guessing right, but I've pulled a fast one on you here. Is that what you were going to guess? 3? Okay. Clay.
2.
Is there a 2 anywhere in that problem? Levi, what do you think? No, 1 would be the constant. Tristan? No. Lily? Huh? No. Quaid? No. Jacob? No. Now, listen. Listen. What is our rule? When we have subtraction problems, what are we always supposed to do? Change it to addition. So, first things first, 1 plus, and we do the opposite of that, which is, so the coefficient is -3. The coefficient is -3, not 3. Now, if I had 1 plus 3x, then the coefficient would be 3. Okay. 3 red shirts stand up, then Jacob stands up. Do we have 4 red shirts standing up? No. That's what your common mistake will be. Huh? Yes, it's just 3. If I have 3 bananas, I have 3 bananas and 2 apples. I don't have 5 bananas or 5 apples. I have 3 bananas and 2 apples. Okay? You cannot put the 2 things together. 3x plus 1, or 1 minus 3x, you cannot put those together. They are in simplest terms. That would be like me. This problem right here would be like this. 1 plus -x plus -x plus -x. Can you say that you have 4 x's there? Can you say you have 2 x's there? No, you have 3. You have 3 negative x's. Okay? And so that's why it's negative 3x. You can't put them together here, so you can't put them together when it's the other way either. Okay? Brandon?
Why did you get the negative from the 1 minus 3x?
Because you have to change all subtraction to addition. That's the first thing. Okay? Because could you do 1 minus 3? You have to change it to addition. Okay? And when you change it, instead of being a positive 3x, it turns to a negative 3x.
Whenever it's like in this type of problem, we change it into addition?
No, every minus, any subtraction from here on out, if I had 2 minus 6, okay, the only way you can do that is change it to 2 plus negative 6.
Oh, yeah.
Okay, that's a legal problem. In fact, I had Miss Cortina the other day. Jonah and Maya's mom teaches 3rd grade or 2nd grade for us, and she was showing me something in math that somebody had a question about, and it wasn't one of her kids. It was an older person, and she started writing that right there, and so I can't do that. And I'm like, yeah, see, you're such in a habit. She said, well, I know it's negative 2, but I said, yeah, and you're in such a habit. Elementary teachers are in such a habit of you can't write it like that. You heard that all probably 1st through 4th, 5th, 6th grade, not 6th because we did it in here. But they said, oh, you can't do 5 minus 7. It's got to be 7 minus 5. Yeah, you can. You can do 5 minus 7. It just has to be 5 plus negative 7. Okay? So that's one of the areas that people will make mistakes in this lesson. Okay, is they will not change subtraction to addition and do the opposite. Okay, now, constant equivalent variable, okay, yeah. We talked about variable expressions yesterday. Okay, we talked about that yesterday at the very first of class. We talked about expressions and equations, and I said, hey, this is a variable expression, not just an expression. Okay, that's what they've covered here. Now, I want to look at, back to our problem that I wrote down, 7c plus 9 minus 3c. Okay? First thing we have to do in this problem, step 1, in simplifying. Change all subtraction to addition. And do the opposite of the term behind the subtraction sign. Okay, so step 1 here would be to change that right there. Stop. Are you writing down what I'm writing down? No. Yeah. Now, I have 7c plus 9. Change that to addition and do the opposite of 3c, which is negative 3c. Okay, that's step 1 in simplifying. Number 2. Number 2 is use the commutative property of addition and rearrange terms to put like terms together. So commutative property says I can take each one of these terms, 7c plus 9 plus negative 3c, and rearrange them, and I won't get a different answer. Okay, in this problem, 7c and 3c are the same. Okay, because they both have the same variable. Okay, we call these like terms. Okay, like terms have exactly the same variable, or all constant terms are the same. So in this problem, what is my constant terms? Okay, I have 7, 9, I have 7, 9c, I have 9. Look at your definition for a constant. What is a constant? A number term by itself. So it's 9. So the only constant in this problem is 9. And we're going to go over that more tomorrow when we finish up this. Okay? So that means that I can do this. 7c plus negative 3c plus 9. That is the commutative property. Okay, I have taken and rearranged the terms and made it where the like terms are closer together. Step 4, or excuse me, 3. Okay, went ahead of myself. Step 3, combine any like terms together following the rules for adding integers. Okay? In other words, 7 plus negative 3. What is 7 plus negative 3? What is 7 plus negative 3? 4. And it's 4c plus 9. Now, I have 4 c's and 9 1's. Can I put them together and say I have 13 c's? No. Can I put them together and say I have 13 1's? No. So that is your answer in simplified form. Okay? We'll finish up the rest of it tomorrow on Friday. You may go.